Arithmetic progression. Question number one. Prove that if nth term of a progression be a linear expression, then the progression be in an if. Let's see the solution. Let's write nth term Dn equals a n plus b, where a and b are constants. Now we write Tn minus 1th term, so that would be a n minus 1 plus b. Now we find the difference. Tn minus Tn minus 1 equal to an minus a n minus 1 plus b minus b. From here, we get a, which is constant. Since the difference between two terms is constant quantity a, so this will represent an AP and a will be common difference. Now, second question. Prove that if sum of n terms of a progression be a quadratic expression, then the progression be in an AP. Let's see the solution. Let's write sum as Sn equal to an square plus bn plus c, where a, b, c are constants, and this is quadratic expression. Now we write nth term Tn, that will be difference of Sn minus Sn minus 1. So we put the values a n square plus bn plus c reduced by a n minus 1 square plus b n minus 1 plus c. So we can take common a, then n square. From here it will be n square plus 2n minus 1, and we take common b from here, so n minus n plus 1, and c will cancel out, so we will get 2an plus b, which is a linear expression. And we know that if nth term of a progression be a linear expression, then the progression will be in AP. Sum of n terms of progression be a quadratic expression, then progression be in an AP. Here we have considered sum as quadratic expression, and we have found nth term as linear expression, hence the result. Now let's consider next question. If sum of a sequence resulting from the insertion of n arithmetic means between 2 and 38 is 200, then what is the value of n? So let's consider its solution. 2, then a1, a2, a3, dot dot dot, an, then 38. So total terms will be n plus 2. We write 38 as Tn. Tn equal to a plus n minus 1 into d. So here 38 equal to a is 2 plus total terms are n plus 2. So this will become n plus 1 times d. From here we can get this 2 will go to LHS, this will become 36, and then divide by n plus 1. So d equal to 36 divided by n plus 1. Now we are given sum as 200, so we apply the formula for sum. 200 equal to n plus 2 term divided by 2 times 2a. A is given as 2. So 2 into 2 plus n minus 1. So here total terms are n plus 2. So it will become n plus 1 times d. This can also be written as n plus 2. This will become 400. We multiply this to LHS. And here, instead of putting the value of d, we can do one more thing. But it's okay. 4 plus n plus 1 into d. So 36 times n plus 1 divided by n plus 1. So n plus 1 will cancel out. So we will get 40 inside the bracket. If we divide it, so 400 divided by 40 will give 10. So 10 equal to n plus 2, which gives n equal to 8, which is our answer. Now, next question. If first term of an AP is A, second term is B, and nth term is 2A, then what is sum of n terms? So an equal to a plus n minus 1 into d. And an is given as 2a. So 2a equal to, first term is a. So a plus n minus 1 into d. So from here, we can get d equal to a upon n minus 1. Now, common difference will be b minus a, d equal to b minus a. And here we have got d equal to a upon n minus 1. So both will be equal. So b minus a equal to a upon n minus 1, or n minus 1 equal to a upon b minus a, which gives n equal to a upon b minus a plus 1, that is a plus b minus a divided by b minus a. A will cancel out, so we will be left with b upon b minus a. Now we apply formula for sum. Sn equal to n by 2, 2a plus n minus 1 into d. We put the values. So n by 2, a plus an, because this thing can be written as a plus n minus 1d, which is a plus an. And we have an, that is nth term, as 2a, and n as b upon b minus a. So we put this value b upon twice of b minus a, and a is a, and an is 2a. So we get, this is 3a. So it will become 3a by 2 b, 3a b by twice of b minus a, which is our answer. Now let's consider next question. If the numbers a, b, c, d, e are in AP with a equal to 1, then what is the value of a minus 4b plus 6c minus 4d plus e? So here, common difference, d will be b minus a, and a is given as 1. So d will be equal to b minus 1. Now, or we can say b equal to 1 plus d. So we can write value of c, d, e, etc. So a is a, b is 1 plus d, c will be 1 plus 2d, d will be 1 plus 3d, and e will be 1 plus 4b. Now we can put this value here to get answer. So a minus 4b plus 6c minus 4d plus e. So a is a minus 4 times b. B is 1 plus d plus 6 times c, that is 1 plus 2d, minus 4 times d. So it will remain here in place of d, here one can write 1 plus, suppose this is d. We can take this d is both term, whereas this d is common difference. So don't get confused. So 1 plus 3d plus e, 1 plus 4d. We simplify it, so we get 0. Now, next question. If the non-zero numbers x, y, z are in AP and tan inverse x, tan inverse y, and tan inverse z are also in AP, then show that x, y equal to y, z. So if tan inverse x, tan inverse y, tan inverse z are in AP, so we can write tan inverse y minus tan inverse x. So must be equal to tan inverse z minus tan inverse y. Now we apply the formula of tan inverse A minus tan inverse B, that gives tan inverse within bracket A minus B divided by 1 plus A. So this will become tan inverse y minus x divided by 1 plus xy, and this will become tan inverse z minus y divided by 1 plus zy. We can remove tan inverse from both sides, so we get y minus x divided by 1 plus xy equals z minus y divided by 1 plus zy, or y minus x times 1 plus zy equal to z minus y times 1 plus xy. Now we can further simplify it. So if we open the bracket, so we will get y minus x plus y square z minus xyz equals from here z minus y plus xyz minus xy square. But we are given x, y, z are in AP. It means y minus x equal to z minus y. So here y minus x, z minus y will cancel out, being equal. Now here we can take common y, z. So y minus x equal to, from here we can take common x, y. So z minus x. Sorry, we are taking our z minus y. But as we know, z minus y, y minus x are equal. So again, these two terms will cancel out. So we will be left with yz equal to xy, and this is the required result. Thank you.